Good morning, my dear students. Hope all of you are fine. I am also fine. Today, I am going to discuss about the chapter 4, a creative question based on chemical equilibria. Dear students, that's why you have to know about the chemical equilibrium first. Dear students, today I am going to discuss about the Chatelier principle. Before learning Chatelier principle, you have to remember about the equilibrium state. You are watching an animation in the screen where a cartoon is trying to go upward, but the skeleton is coming to downward. Here actually the upward velocity and downward velocity are equal to each other. That's why the cartoon is at the fixed position. It means it can't go upward, even it does not come back to the backward. This is actually an equilibrium system. If I match this equilibrium system with the chemical reaction, then the definition will be like this: the state at which the rate of forward reaction and the rate of backward reaction are equal to each other is called chemical equilibrium. The equilibrium state, if any of the factor of reaction is changed, then the equilibrium is changed in a such way where the effect of change of factor is relieved. Look at the whiteboard. At 500 degrees centigrade temperature and 50 atm pressure, nitrogen gas and hydrogen gas react together to produce 25% ammonia at the equilibrium state, and 92 kilojoule heat is evolved. So first question is, determine the term of Kp for the occurred reaction of the stem. Dear students, first you have to write the occurred reaction. Nitrogen reacts with hydrogen to produce ammonia. Here the delta H is equal to minus 92 kilojoule. As I need to determine the term of Kp, here I need not to mention the delta H value. However, dear students, at the initial state, the mole number is 1 mole and the mole number of hydrogen is 3 mole, and there is no product at the initial state. But at the equilibrium, if the degree of dissociation is alpha, then I can write here 1 minus alpha mole, 3 into 1 minus alpha mole and 2 alpha mole. So total mole number at the equilibrium is equal to 1 minus alpha plus 3 into 1 minus alpha plus 2 alpha is equal to 1 minus alpha plus 3 minus 3 alpha plus 2 alpha. So the result will be 4 minus 2 alpha. Dear students, the partial pressure of nitrogen is equal to the mole number of nitrogen at the equilibrium is 1 minus alpha divided by total mole number 4 minus 2 alpha into total pressure P. Let the total pressure is P. as well as the partial pressure of hydrogen is equal to the mole number of hydrogen at the equilibrium state 3 into 1 minus alpha divided by total mole number 4 minus 2 alpha into P, as well as P is the total pressure of the reaction system, and the partial pressure of ammonia is equal to the mole number of ammonia is 2 alpha divided by the mole number, total mole number at the equilibrium is 4 minus 2 alpha into total pressure P. And we know that Kp is equal to partial pressure of the product PNH3 square divided by partial pressure of the reactants. Then I have to put the values of those partial pressures. Ammonia 2 alpha P divided by 4 minus 2 alpha whole square divided by 1 minus alpha by 4 minus 2 alpha into P into 3 into 1 minus alpha divided by 4 minus 2 alpha into P whole bracket cubed. So dear students, I would like to show you shortcut here because of shortage of the whiteboard, because of the shortage of area of the whiteboard. So Kp is equal to 16 alpha. So Kp is 16 alpha square into 2 minus alpha whole square divided by 27 P square into 1 minus alpha whole to the power 4. This is the term of Kp. Now dear students, come to the question number 2. Here also I have to write nitrogen gas plus 3 molecules of hydrogen gas and reversible sign 2 molecules of ammonia gas. And here the ratio of the mole number of nitrogen and hydrogen is 1:3. Sum of the ratio is equal to 1 plus 3 is equal to 4. At the equilibrium state, 25% ammonia gas is produced. So I can write here mole number of NH3 is equal to 25 mole. So the mole number, of course it will be at the equilibrium state. So the mole number of remain nitrogen and hydrogen is equal to 100 minus 25 mole is equal to 75 mole. Now my question, how can you understand that which will be the mole number of nitrogen and mole number of hydrogen among 75 moles? Yes, dear students, I can calculate the mole number of nitrogen and hydrogen separately by the calculation. So, mole number of nitrogen is equal to 75 into 1/4 is equal to 18.75 mole. Mole number of hydrogen is equal to 75 into 3/4 is equal to 56.25 mole. Students, now I have to calculate the partial pressure of ammonia, nitrogen and hydrogen. So the partial pressure of ammonia is equal to mole number of ammonia 25 divided by total mole number 100, because in the question it is stated that the total mole number is 100. 100 is for percentage, into total pressure. Total pressure is 50 atm. So what will be the result? 12.5 atm. And partial pressure of nitrogen is equal to mole number of nitrogen 18.75 divided by total mole number into total pressure. So the result is 9.375 atm. And partial pressure hydrogen is equal to mole number of hydrogen 56.25 divided by total mole number 100 into 50 is equal to 28.125 atm. Now we can write Kp is equal to partial pressure of the product PNH3 square divided by partial pressure of reactants PN2 into PH2, and the coefficient will be the power. Then I have to put the values. Ammonia 12.5 square divided by nitrogen 9.375 into hydrogen 28.125 cubed. So the result Kp is equal to 7.49 into 10 to the power minus 4 atm inverse 2. This is the answer. Now dear students, look at the question number 3. How maximum product is produced by the application of Le Chatelier principle. So we have to write the reaction here. By the observation of this reaction, I can write here, this is a reversible reaction. Reversible reaction. And number 2, this is an exothermic reaction because the delta H value is negative. And third number is, in this reaction the volume of the gaseous reactant is decreased, and it is decreased from 4 to 2. For the production of maximum ammonia, I have to use optimum temperature. Dear students, this is an exothermic reaction. So, according to the Chatelier principle, if I apply heat, the equilibrium shifts to backward, but if I decrease the temperature, equilibrium shifts to forward. But at low temperature, the rate of reaction is also low. This is a contradictory condition. In this condition, optimum temperature is applied here to produce maximum ammonia, and in this case the optimum temperature is 450 to 550 degrees centigrade temperature. And number 2, catalyst. To reach at the equilibrium rapidly, iron catalyst is used to increase the catalysis property. To increase the catalysis ability, molybdenum is used as catalyst promoter. Then pressure. Dear students, if you observe the reaction, you will see that both of the reactants and products are at the gaseous state, and here the mole number of gaseous reactant are 4 and the mole number of gaseous product is 2. So, if pressure is applied according to the Chatelier principle, the equilibrium shifts to forward to produce more ammonia. But applying high pressure, the required instruments are very costly. So, to get more ammonia, the minimum pressure 200 to 250 atm pressure is applied here. Dear students, I would like to clear your concept about the effect of pressure on the equilibrium state according to the Chatelier principle by this animation. According to the Chatelier principle, if pressure is released, then the volume of the gaseous system will increase, and if pressure is increased, then the volume of the gaseous system is decreased. It means the volume of the gaseous system will change its position to relieve the effect of applied pressure. And dear students, in the screen you are also seeing the reaction of ammonia. Here 1 mole of nitrogen reacts with 3 mole of hydrogen to produce 2 mole of ammonia. Here if pressure is increased, the reactants molecules convert into the product molecules. I mean the forward reaction rate is increased to neutralize the effect of change of pressure. According to the Chatelier principle, after applying 200 to 250 atm pressure, maximum ammonia is produced. And number 4, collection of ammonia. After production of maximum ammonia, the equilibrium will go backward. In that case, the product ammonia will be decreased. It will be a loss project. That's why after some time the ammonia should be removed from the reaction system to be hindered the backward reaction. By this process, maximum ammonia can be produced by the application of Chatelier principle. So, no more today. Goodbye and may Allah bless you.